regarding threads. This is lesson 4 and I have uploaded this in your Google Classroom as well. Oh, yeah, Google Classroom in your respective sections. Okay, so threads. In this lecture, we will define and we will also try to discuss each uh, all of the lessons or all of the units that is being written in the the module or in this lesson for threads. So thread is also an important topic in operating system. In the previous discussion, we also discuss what is process. Process and threads are two uh, most important topic when we talk about operating system. So, just a little review. Diba a program, when the program is already starting executing, is or is started executing, it is known as a process. So, if the program is just in a standby mode, it is not executing well, it is not yet in the CPU, it is not yet in the main memory, meaning it's not yet a process. So when the program starts, that is what we call a process. Now, on the other hand, a thread is a basic unit of execution. So each program may have a number of processes associated with it. And then each process can have a number of threads executing in it. So meaning to say, a program may have number of processes, and each processes may also have number of threads executing in each process. So basically, a thread is a unit of execution or a basic unit of CPU utilization. So a basic unit of CPU utilization, so that is what we define as a thread. So a thread is a basic unit of CPU utilization. That is what is being written in your module. And each thread is comprises of, we have it's comprises of, we have the thread ID, a program, we have a thread ID, we have a program counter, a registers or a thread ID, a set and a stack. So each thread comprises of a set of these four unique items, and apart from this, it shares uh, with other threads belonging to the same process. So we have codes, the data, the files, and other operating system resources. So such files and signals, so as I told you before, a process can contain different processes, or a program contain different processes, and then a thread belonging to the same process will share the same resources. So what we have here, diba, we have two. Let me maximize this one first, zoom out this first. Okay, so we have here two we have here two diagram. So let's start to explain this two diagram, so that uh, we can differentiate what is single threaded process and the multi-threaded process. And the first one is a single thread process. So a single thread process, we also call this a traditional heavyweight process. That is what we call a single process. So each process, this whole block here, is considered to be uh, one process. So kaning isa ka single thread is considered to be one process. And this process contains only one thread kani. This one kanang murag na pagka uh, zigzag. This is considered to be one process with one thread. So that is what we call single threaded process. So this section belonging to the same process. So there is only one thread, and this process can perform only one task at the same time. At a time. So the contrast, this we have code, we have data, we have files, and then we have registers and tasks. So obviously, in the single thread process, we can only process, or we can only done one task at a time. Now, in contrast with this, the diagram beside the single thread process is the multi-threaded process. So in this diagram, it shows multi-threaded process. So this whole block here is considered to be one process. It's represent multi-threaded process. So you can see there's three threads. There's three threads. Each of these threads, they have their own stack, register, stack, registers, stack, register. So each thread is designated to have its own register, stack, register, stack, register, stack, the three thread. However, one they have they also shared one code, data, and files. Wait a moment. For a while, I'll be back. I'll continue later. Okay, so again, I'll continue my lecture. So, as have you, if you have with you a copy of the module, we have two types of thread processes. So we have the single thread processes, and then we also have the multi-threaded processes. So a single thread process is also what we call as traditional or heavyweight process. So it has a single thread of control. So as you can see, uh, it contain one thread only. So this all block here is considered to be one process. So usa ni siya ka process. This one diagram is considered to be one process. So we only have one thread, and then these are the resources. We have the code, the data, and the files, and then we also have the register and stack. So obviously, this thread or these single thread processes can only process one task at a time. So one task at a time. But in contrast to the next diagram, this is considered to be a multi-threaded process. So in this process, it can this whole block here is represent a multi-threaded process. So as you can see, there is three threads. The zigzag one is has have a three threads, and then each thread has its own register and stack. So for this thread, we have register and stack. For the second thread, he also have the register and stack, and so with the third thread, the register and stack. And these shared same resources. If you can see it, wala siya divide. So it's actually centralized, or it is shared to all the three threads. We have the code, the data, and the files. The resources, the code, data, and the files. So so all of these threads have their own stacks and register, and they shared same resources. And if you also see on the top here, here, each file section, each data section, and each file section is considered to be uh, centralized for all the three threads. So this is a diagram of a multi-threaded process. So in this case, since it is multi-threaded process, it can actually process multitask at the same time. So it can perform different tasks using these three threads at the same time, because this thread will be performing different tasks, and hence multiple tasks can actually be processed within this type of diagram. So in most of our system today, in most of the systems that we use, may it be desktop, laptop, iPad, or so many other devices, we are actually using a multi-threaded process already. So we follow this system since, di ba, let's say for example, if you are using your desktop at home, or if you're using your cell phone or your laptop, you can really imagine that we can use, or we can actually utilize many application at the same time. Let's say for example, nag music mo, and at the same time you're using the dot doc or the word, and at the same time you're watching YouTube. That is actually a multi-threaded process wherein all of the resources are being shared with those threads, multi-process. So you can actually you can actually uh, you can actually imagine these processes if i-try lang ninyo og kanang control alt delete. You can see there in the task manager wherein na mga processes dito, and then pila na ka memory ang nagamit, unsa na nga percentage sa CPU is actually using. So that is somewhat you can monitor if what are the processes or what are the memory or how much is the memory is being used when you're using a multi-thread process. And there are also some benefits of using a multi-threaded process. So we have there are four: uh, responsiveness, we have resource sharing, and then we also have economy, and then scalability. Now, when you say responsiveness, one thread may provide rapid response while the other threads are blocked or slowed down doing intensive calculations. So how is it benefited, or how is the multi-threading benefit the user who are uh, using the multi thread processes? So an interactive applications may allow the program to continue running even if it is blocked or perform a lengthy operation. So therefore increasing the responsiveness to the user. So for example, we can see that it is really responsiveness if we use multi-threading. Let's say for example, we are using a web browser. Since we are using different threads, or we are using multi thread process, as we are momentarily we are using web browsers. That is for the, let's say for example, nag browse mo og research or na google mo, and then the other one is also downloading, and then the other one is also for interaction. Let's say for example, nag Facebook mo, you are chatting, and in YouTube you are actually downloading a video, and then in web browsing you're actually googling something. So it's actually the whole point of being responsiveness when you are using multi-threaded process. Now, however, if you are using one thread only, then you can only, if you're using a single thread only, then there was only one, or there's only one process to be there's only one process, or there's only one applications that you can actually use. You can only access other applications unless one of unless one of your other tasks have finished already. So let's say for example, if you're using a single thread process, so meaning to say, the thing that you can only process one task at a time. So mag web browser ra mo, or you're going to web browsers, but you cannot chat at the same time or download at the same time because you're using one thread only, meaning to say ang resources ninyo is only one. Whereas when you are using multi-threaded function, you can actually multitask at the same time, since it is three thread at the same time, and then you are sharing resources. So the users have to wait. If you are using single threaded only, the user have to wait for one of the tasks to complete in order to go and to the next task. Now in case of multi-threaded, the responsiveness to the user is actually very high, since you can work faster, and then you can multitask, you can finish a lot of tasks at the same time. So it can make your lives even better, or if you can make your work even better. Now the second one is the resource sharing. So a resource sharing is, by default, threads are shared common codes, data, and other resources which allow multiple tasks to be performed simultaneously in a single address uh, space. So when we say uh, resource sharing. So threads share the memory and the resources of the process. So if we have to go back to the this one, this diagram, resource sharing, because you're actually sharing code data and files, meaning to say you're actually sharing the memory and the resources of the process. So you can actually do multiple tasks simultaneously. So same with the responsiveness example. So at the same time, you can actually print, you can also save, and you can also work on your data, or work on your or you have documents to finish using the Microsoft Word. So those are resource sharing. So you can actually use resources at the same time when you are in a multi-threaded process. So it's actually one that can benefit you if you're using multi-threaded process. Then the next one is economy. Creating and managing threads and context switches between them is much faster than performing the same task for processes. So we can actually make our system more efficient. So, economy is allocating memory and resources for process creation is costly. So, economy meaning to say you don't have to, time wise also, you don't have to do things the same thing over and over again, and it will cost you a lot of money because let's say for example, if you have to do many many things or many report at the same time, and then you cannot do it uh, simultaneously, so it really costs your time, not just your time but your money as well. Now, scalability, that is the utilization of multiprocessor architecture. So a single thread process can only run on one CPU, no matter how many will be available, whereas the execution of multi-threaded applications may be split amongst available processors. So since it is a multi-thread process, you can actually the utilization of the CPU can actually split into many things or into many parts, since you're using multi-thread processor. You can actually do things you can actually do quite a lot of things at the same time. So diha na lang na siguro mag difference within the memory that you are using. So I hope you understand the difference between the single thread process and then the multi-threaded process. I know I'm quite but fast in discussing, but I want you to review again, and then if you have any questions, please let me know. I just would like to kuan lang gud to differentiate, or to emphasize again that a program may contain, or may contain different processes, or may have many processes associated with it. And then a process is can contain many threads while executing on it. So program, when you say program, a program under execution is known to be a process. So meaning to say, once the program is started executing, we will call it a process already. Now, a process may have a number, or a program may have a number of processes, and each processes can actually have many threads when we start executing it. So ang the point here is a thread is actually a basic unit of execution. So mo nang by this one, we have a single thread process, and when we have a multi-thread process. So this process is actually sharing one resources only, and then this can actually perform one task only at a time, whereas this multi-threaded process is actually sharing resources like code, data, and files, and then each thread have its own register and stacks. So this can actually process multitask at the same time. Okay, and then we also have these benefits. So again, if you have any questions or clarifications or whatsoever, please don't hesitate to message me in the group chat. Okay, and then thank you for listening, and I hope you have a good day.